Hello students, now we are going to discuss about the electrophilic substitution reactions of nitration and sulfonation. So let's start with the very first reaction, that is nitration. We already have discussed about bromination, right? Now, what is nitration is the basic question. What is nitration? Nitration is nothing but a reaction in which a nitro group is introduced. And how is it done? Let's see. We take a molecule of aniline for this, and to this molecule of aniline we are adding concentrated HNO3 in the presence of concentrated H2SO4. That means it is a nitrating mixture. Now, we have already discussed into the previous modules that NH2 is an orthopara activating group, right? That means we should get the first compound, that is orthonitroaniline. The next compound should be para-nitroaniline, and the third compound should be meta-nitroaniline. Now, who should be the maximum? It should be para and ortho. And who should be minimum? It should be meta. But a case reverse than this is happening over here. Let's see. Ortho we obtain in the concentration ratio of only 2%, whereas para is 51 and meta is 47. Now, what is the reason why meta is so very huge in concentration? Let's see. Now, what happens into this reaction is when aniline is treated with an acid, that is H+, what happens? Nitrogen donates its lone pair towards hydrogen, giving us rise to an ion called as an anilinium ion. And remember student, anilinium ion is an electron withdrawing group. That means it would deactivate ortho and para, whereas activate meta. So this was all about the reaction. Now let's see one more thing into this reaction. What if we want only a mononitrated product? Let's see what we can do. Take a molecule of aniline, treat it with acid anhydride in the presence of pyridine. So what we have done, we have taken acidic anhydride. Now what happens? NH2 consists of 2 hydrogen. Out of this, 1 hydrogen combines with CH3 C double bond O, giving us acetic acid. And now what we are left down is nothing but a compound, that is acid analyte. Now, to this acid analyte, if we add our nitrating mixture, that is nothing but what? HNO3 and H2SO4. Then what would happen? Just before this, let's remember, NH2 is a group that is basic and analyte is a group that is nothing but neutral. So now what would happen? Let's see in this case. Whenever we add a nitrating mixture, what happens? OH and H from the para position gets combined, giving us water. And to this, what we would get now? We would get a compound that is para-nitrated compound. Now when this para-nitro acid analyte is hydrolyzed, the nitrogen carbon bond gets broken down, hydrogen gets added towards nitrogen, OH gets added towards carbon. So what do we get right now? Do we get a molecule that is CH3 C double bond OOH? Yes, that is acetic acid. And along with this, we get a compound that is aniline attached to nitro on the para position. Well, the name of this compound becomes 4-nitroaniline or para-nitroaniline. So this was all about nitration. Let's now move towards the sulfonation reaction. Now what exactly do we mean by sulfonation reaction? Again, sulfonation is nothing but the addition of SO3H group. Let's see how this is done. Let's take a molecule of aniline. To this we would add concentrated H2SO4. Now concentrated H2SO4 can be written down as HSO4. What you would get? Let's see. Nitrogen donates a lone pair towards hydrogen, giving us benzene ring attached to NH3 positive, HSO4 negative. Now what would happen further? Let's see. Now this same NH3HSO4 is written down something like this. Now what happens? from the para position of benzene, a hydrogen is lost. From NH3 positive, one hydrogen is lost, and oxygen from SOH 4 times, one oxygen is lost. Because of this, what do we get? We get a molecule of water. Now what we are remaining is nothing but a compound, that is benzene ring. Onto the main location there is an H2, and onto its para location there is SO3H. Now what happens? A very interesting formula, a very interesting fact over here. We all know NH2 is a group that is basic in nature, whereas SO3H is a group that is acidic in nature. Now, as it is an acid, it would donate one hydrogen towards NH2, and thus what we can say, as the compound consists of both acidic and basic groups, it would give rise to a Zwitter ion, giving us a compound which would be called, or which would be named something like this, which has a structural formula something like this. Now in this, onto the top hand side, do we have a positive? Yes. Onto bottom side, do we have a negative? Yes. Therefore, this would be nothing but a Zwitter ion which would be formed. This was all about the reaction of sulfonation and nitration. Meet you in the next module. Till then, thank you students.